In this video, we are going to look at the vector product of two vectors. So we're going to look at how to actually solve the vector product, what it actually means, and how we can relate this to some common IB maths exam questions. So I've given you two vectors here, A, B, and AC, and if I want to find the vector product, you may also see this as the cross product. The cross product. So these are the two ways you might see it, vector product and cross product. They do mean the same thing. And this is different to the dot product, the scalar product, where we did in a previous video. And the scalar product or the dot product, that gives you an answer which is a scalar. It's just a number. And we use that if we want to find the angle between two vectors. But this time when we use the vector product, it actually is going to give us another vector. And what that vector is some vector in a plane that will be perpendicular to both of these two vectors. And I will touch on this after we've calculated the vector product. So let's go ahead and do that. So if I want to find AB and AC, the vector product of these two, what we want to do is we want to set up this matrix. So we put a line here, and the top row we put I, J, and K. Our second row needs to be the first vector in our vector product equation, so AB. So it'll be 2, 3, and 5. 2, 3, and 5. And then the last row, the third row, will be the second vector in our vector product, AC, which is 1, 2, and 4. Okay, now to solve, to find our vector product, we need to use this system here where we look at firstly I, and we need to find the I component of our vector product. And the way we do that is we cancel out the rest of that row and that column, and we have 4 numbers left over. And if you have done any matrices before, or you've heard the word determinant, that's what we need to do. We need to find the determinant of these 4 numbers. If you haven't heard of the determinant or any matrices, all you need to do is you need to multiply this leading diagonal and then subtract the other diagonal. So it'll be 3 times 4, take away 5 times 2. So let's do that. So we're going to have 3 times 4, which is 12, minus 5 times 2, which is 10, and this will be our I component. Okay, now the second component, our J, something to remember, and unfortunately a lot of students forget this, the J term, before we put something J, this always needs to have a minus sign. So we need to put a minus only in front of the J term. Okay, so J, let's ignore the rest of that row and the J column, and we use the other 4 numbers. So 2 times 4 is 8, and we're going to subtract 5 times 1, which is 5, and that's our J term, and then plus, and for the K, we will go 2 times 2, which is 4, minus 3 times 1, which is 3, and this will be K. Alright, so now let's find our final answer. So 12 minus 10 is 2I, and then we're going to have minus 3J and plus 1K. And we could write our vector as 2, negative 3, 1. Okay, so that's how we do the vector product. Hopefully you followed those steps. AB, the cross product between AB and AC is different to AC-AB. It's actually the negative answer. Because notice that the rows would be different, so these equations would all be slightly different, and you'll get the negative answer of this. So this is the vector product answer. Now, you may have seen in your textbook, or your teacher may have referred to the right-hand rule. What the right-hand rule says is that if we have two vectors, for example, what we have here, AB, where this is point A, this is point B, and this is point A, this is point let's say C, the vector which is perpendicular to both of these two, AB and AC, this is quite hard to show you on a two-dimensional screen, but picture this, the screen that you're watching this video on, both of these lines are on a two-dimensional axis, they're on your screen. And this vector product here, this vector that we had as our resultant, this will actually be coming out of the screen or into the screen. It'll be perpendicular to the screen that you're watching this on. So it's either going to come straight out at you or it's going to go into the screen. And to determine which way it's going, you need to look at what the order of the vector product, and if it's A, B, and AC, and we know that A, B, and AC have this shape here, we look at the first vector AB, and you need to try and align your right hand, so get your right hand out and align it to AB, so your right hand should be going across this vector here, and then you want to try and slightly fold your right hand into the second vector AC. And if you've folded your right hand into that, have a look at where your thumb is pointing, and if you've done this correctly, your thumb should be pointing up. It should be pointing up out of the screen, and that tells you the direction of this vector product resultant here, because we know that this should be perpendicular to both of these, and if it starts here, it's either going to come out of the screen or into the screen, and for this case it will be coming out of the screen. If we wanted to do the cross product of AC and AB, this would be slightly different, because if you aligned your right hand to AC and tried to curl your hand into AB, it would be a long way to curl, so this actually wouldn't work. You would need to flip your hand such that your thumb is pointing into the screen, and then you would curve your hand into AB, and therefore you will realize that your thumb will be into the screen, so you could make the assumption that the vector product will be going into the screen, not out of the screen. Now this is very important when you're doing the vector product of things in real life, and you want to work out whether it's going in one of the dimensions, either up or down. Okay, so the key concepts of this video is knowing how to find the vector cross product. The other important thing that we need to know is that if we have this triangle here of two vectors and we want to find the area enclosed by this triangle, this area here, the cross product does help us find this area, because the area of this triangle will be a half multiplied by the magnitude of the resultant vector product, AC. So this vector that we just found here, if we take the magnitude of this, just using Pythagoras, and then multiply that by 1/2, we've actually found the area of this triangle. And if you don't have the half here, if you ignored the half, you would actually be finding the area of this parallelogram here. So if the question does ask you to find the area of the parallelogram, we don't need the half. If it asks you just to find the area of the triangle, you would put the half out the front. Okay, I encourage you to practice some of these questions, so good luck.